Hey students, welcome back. So on our previous video, we learned how to write full-blown electron configuration, and you'll need to view that video if you have not before you do this one, because otherwise this one probably won't make sense. Also, if you're looking at it for missing class purposes, please check out the bell ringer that's posted on the announcements on Canvas. Okay, so today we're going to learn how to do shorthand, and I know you're super not excited saying there, oh man, there's a shorthand way and you had to teach us the longhand way. Trust me, I've tried to teach only the shorthand way and it hasn't been positive, so that's why we're going for the whole way here. All right, so we're going to start with shorthand electron configuration, and we're going to start with a definition of noble gases. So our noble gases are group 18. All right, but we also want a definition. Why are they called noble gases? And we'll get more into this later, but they have a full valence shell. All right, and a full valence shell means that the outer energy level of the element is full. All right, so no more electrons can be placed in it. So that's something to remember for later. All right, so let's take a look at these electron configurations of neon, sodium, and aluminum, and see if we can't figure out maybe how this shorthand works. So if we look at neon's electron configuration is 1s2, 2s2, 2p6. Sodium's is 1s2, 2s2, 2p6, 3s1. All right, let me put that one up top. Aluminum is 1s2, 2s2, 2p6, 3s2, 3p1. Now, hopefully you notice something that kind of look the same throughout, all right? Look at this and how it's present in each of them, right? The 1s2, 2s2, 2p6. And we said having a full valence shell, that actually makes you unreactive. So that's our way of kind of getting away with using, we'll say the noble gas prior to it is full. So how we do it is we find the noble gas prior to it in group 18. Remember, group 18 is our noble gases. If we have not numbered that on our periodic table, it is the far right hand column with neon, helium, argon, krypton, xenon, and radon. All right. We're going to so the first thing we're going to do is we find that noble gas, then we put that noble gas symbol in brackets, then we start with that next row, whatever row we're in, and with that S and continue. That way we don't have to remember that whole long formula from yesterday's notes, okay? So let's see if we can't do this. Hopefully you have your periodic table handy. If not, go grab it real quick and let's see what we got. Okay, so sulfur. All right, sulfur has 16 electrons. It's S, all right? So what we're going to do is we're going to work back and we're going to look at the noble gas in the row prior to sulfur. So if we find that, that's going to be neon. And so we're going to put Ne in brackets. So that means we have 1s2, 2s2, 2p6 kind of already taken care of, so we don't have to worry about that. So we start with the next row. So sulfur is in row 3, so we're going to say 3s2. All right? So if we've got neons 2 or 10, and then we've added those 2 from the S, we're now at 12. Then we keep rolling, and we've got 3p4. So it should be 3p4. If we add up our superscripts, 4 plus 6 is 6, right? Or 4 plus 2 is 6. And then we've got neon, which is 10. So we're at 16. So we've done our job. Awesome. Okay, let's try a little more difficult one. And I also wanted to throw noble gas in here because sometimes we get a little confused. So we have xenon. Xenon is 54. It has 54 electrons. And just like we had fun yesterday doing 10, this one will be so much easier because we're going to do the shorthand. So then we have to find the noble gas prior to it, and that's krypton. All right, xenon is in row 5, so we're going to start with 5s, 5s2. And if you go back to the little cheat sheet that I gave yesterday, after 5s2 was 4d10. All right. Or you can use the periodic table. And if you want to ask me in class how to do that, we will definitely do that. And then we say 40, 10, and 5p6. And there we have it. If we add up our superscripts, 16 plus 2 is 18 plus kryptons, 36. That gives us 54. All right. Let's try iron. Okay. Iron is Fe. It has 26 electrons. All right. The noble gas in the row prior to it is argon, so we're going to put Ar in brackets. Then iron is located in row 4, so we're going to say 4s2. And then we know we're in the d orbital, so we're going to count across our d's. 1, 2, 3, 4, 5, 6. We're going to say 3d6. And there we have it. That's the shorthand electron configuration for iron.